Okay, let's continue where we left off. So we're going to start building our building assets now. What I'm going to do though is I'm going to, so I save this file as 05 underscore procedural buildings part 1. Previous file, apparently we saved this 3, so let's rename this as 4, so this video can be so the previous video will be number 4, and this is where we show the spice pyro, and then we end up the secondaries there. We have to still plant the trees, wait them to grow, but now basically video 5 is going to be the procedural buildings. All right, so let's dive inside our asset creation terrain. So let's create a geometry node here. Okay, now let's rename this node as city source, or building source, building generator, maybe a better name than what I previously had, generator. Okay, now let's dive inside and start our base. So my base starts with a tube basically. So it's literally a tube, and its attributes will be driven by some other attributes. And some seeds that are coming from a null that is driven by a wedge value. So let's call this seed. Okay, so this seed is going to have a float. Actually an integer will do. So it's parameter interface. Let's create an integer. Let's drop it here and let's call it seed. Okay, so just something that gives me some values. Now on the tube, let's get a height value that is a random value driven by seed between 50 meters to 400 meters. That's a long, tall building because these are futuristic buildings. Maybe a bit too tall. So the expression will go as fit. So rand, reference to the channel of the seed. So it's going to be double quote it's a channel dot slash. The name of the node is seed. The attribute is seed. Close quote. And this is fit between 0 to 1 and 50 to 400. Actually, this is not 0 to 1. The seed itself is no, because it is, yes, I'm using the seed value to create a random value which is 0 to 1, so this is correct. So if I do height here, and if I pin this, hit P, this value is going to change. So it's like for every seed it gives us a different height. If I visualize this here, now let's do convert this to polygons. Let's do rows 50, 50, and I'm gonna now copy the values from the other side, my other monitor, so we don't waste time. It's the same thing pretty much, but now I'm saying my base radius can be my top radius can be between 15 to 40 meters times 0.2. So I guess I didn't like one and I made it smaller. Now let's get the base radius, which is 0 to 40. And what you want to do is you want to get the total height, divide by 2. So right click, copy, paste, divide by 2. So it sits on this position. So this is our base shape. This could be this is just to drive the very basic overall shape of the buildings. It's not the actual shape. So what I did next is I'm creating a density attribute because I'm going to, actually I don't use that one, so I'm going to skip that one. Apparently I'm not using it. I'm just going to make sure that I'm not using it, which I don't think I am. Not really, no. Then what I do is just I create a mountain swap. Oops. Mountain. Now I'm going to show you what this does. It's just going to break everything, right? And I am going to use the seed again, so it's random every single time, and put it to offset X. So random at building seed. Oh, okay, so basically I am referencing to the wedge value, but rather I can also just say the same thing I did here, which is seriously the same thing. So let's just go like this. And it's just going to give me a random number. It's just to a random offset. So height is 91, size is 37, just something super random. Again, if I change this, then it's going to change. All good. Now let's scatter some points. So this part is a bit important. This value is going to drive how long it takes to create the basic shape. More you get, more points you get, less mountain you get, straighter walls you will get. Okay. Let's call this edge breakup then. Next thing I do is I randomize an attribute called scale. Attribute randomize, using the attribute randomize not. So scale, as opposed to p scale, is a vector and allows you to drive the scale values non-uniform. So we're creating a 3 dimension, so we have this, as you can see, 3, but my current values are 1 to 11 and 2 to 4. Again, these values are for experimental reasons. I, you know, kind of like put a camera here and start playing with this. Okay, this looks like a futuristic building. I can use this, and basically I end up like that. All right, am I using this second node? I am not even sure, but I will keep it in case I reference it somewhere else. I think I'm returning the X. So basically I'm trying to get a value driven by the relative bounding box. So let's drop a WOP. Point WOP will do. I think I use it somewhere, just why not just create it. And it's also good to know anyway, so I can show you what that means. If I disable these two, it will be easier to see. Put a relative bounding box. So this gets the relative bounding box of an object based on point position. And if you do a vector to float, then you can get fall-offs like x-axis, okay, or z-axis, or y-axis. You can use this some places. I am going to put this now because I'm not sure if I used it anywhere, but it's in my scene. It's been a while because that was the first thing I made for this tutorial. So now when you get back to it, when I get back to it, it's kind of like, oh, not sure. So better safe than sorry. Bind export, I am calling this one X. Duplicate, and I'm calling this one Z, and let's leave it at it. Moving forward, let's enable these guys back. So we should now have scale attribute and X and Z attribute as well. Now, I want to group some of these points. I think I'm not using the cluster attribute as well, but let's keep it in case you want to create different style houses. So I'm gonna copy paste this as well to the clusters. So what is this doing? I want cluster points, just points. I don't need to color them now. Well, actually, let's color them now. Let me put this on black background so you guys can see it a bit better. So it's creating clusters. Oh, okay. I am using the X as a threshold, and so it's not even doing anything actually. Y, it should be doing X as a, it should be distributing points a bit better. this is not really doing anything. Maybe I have glass. Yeah, okay, so this should be doing something. It's just creating different clusters like 0, 1, 2, 3. But I think I was copying different objects based on cluster names, but that was actually on my Elite Fallen tutorial. I'm not even using this, I think, because these buildings are more Earth-like. Let's call it that way. Okay, so now we have these random scattered points that doesn't look anything like a building. So Tim, what are you going to do with this? So let's create our building blocks now. Our building blocks are based on a box that is 4 by 4 by 4 and uniform scale is 10. So that's our building block. Now I'm going to create a normal. I want this to be harsh edges. So 10 creates like harsh edges on vertices. And I need this as well. Okay. Now I do something like this. I put a tube that is end caps turned on. It's also a polygon quadrilateral. That's a mouthful. I think, but its shape and size, I'm just plugging this guy here, so it's kind of like similar to this. Okay. And it's 4 by 6. A bit simplistic. Let's create another normal here. So it's again hard edges. I'll bring this down here. Now let's create another tube, but this time 4 by 48. So this one is like spherical, cylindrical, sorry. And that's it. Now let's put a switch and let's plug these guys in. Okay. There's a variant way now. I found this later, but this is also the same thing. So what I want to do now is I want to say copy all these to these guys, right? Using the scale value, so on and so forth. So then I'm gonna run this in a for each loop, for each point. Plug this guy in here so it fetches 1 point. I'm gonna put a null. I'm gonna name this point to copy. Frankly, I think the variant way is a bit better way to do it, but you know, I did it this way, so we'll just continue doing it this way. So copy the points, left input, right input, and output. So what do we do? If I just press this now, it's going to be like it's just inheriting the points, but it's already like kind of looking like a building, you know. And if we just change the seed, you know, it's just gonna do this. But what we are not doing is not creating a variation between the switches, and we can actually, I think in this tutorial we don't even have to, but let's do it anyway in case you guys wanna do some differences. So let me slide this up. So obviously the switch needs a value. So because we have, I think I had 4 inputs, maybe I had another one, so I'm not going to break this. I'm just going to create this one here as well. Oops. Let's go here. I think this one was, it's the same. Let's go 4 inputs. Later we can change them. Okay, let's put this guy here. So these are called my building blocks. So the more you can spend a bit more time on this, but to get some nicer shapes. But I think this is already like, you know, in a way, somehow, if you scatter 1,000 of these, it will look like some cityscape kind of thing. But we want to see to drive the switch, so they're not always boxes, right? So let's do something like this. I'm also trying to figure out where's my minimum point so I can snap this guy up. So after I do the trying to make sure that nothing is at the bottom. So let me show you what I mean by that. So we copied some stuff and they are at the bottom here. We could have simply used a clip, I guess, but I want to detect if anything is under 0. I want to push that up, and the way I do it is somehow like this. So here I'm going to say f at minimum py equals at p dot y. So I'm also showing many ways to do simple things. There's a ton of way of doing this exact same thing, but if you want to push geometry up, you can do something like this. Attribute promote. Let me actually do this one, then I'll show you how the other way works. So I'm going to say point to detail. I'm going to say mean py, because I'm looking for the smallest number. So the basic, it means like the biggest minus number. So I'm promoting min y based on minimum value. So if I look here, the deepest point in this scene is minus 35. Then I'm going to say drop in an attribute wrangle. Second input goes here. Then I'm going to say, actually copy paste this, I'm just going to explain this. Float min p equals to the detail attribute named min py from the second input. And if it was a vector, it could be 0, 1, 2, but this is not a vector. So as we can see, it's a float. So it takes the 35 and it says, it creates an attribute called min p, and then min p, if any position here is less than min p, then shift everything up as much negative value as there is positive value, absolute min p. So it's like, it means p dot y, let me see here, right? My smallest value is this. So it says, oh, okay, the furthest value is minus 35. Take that value, convert it to absolute, so 35, and add everything to py. So then everything shifts up from here to here, right? So then if I do that, now everything is aligned at the base. Okay. I think I'm not doing any switches here. So a switch is going to be connected to a random value of this guy. So we can just actually copy this, right? But I'm going to change it a little bit because it's 0 to 4. But we have how many? 1, 0, 1, 2, 3, right? So you can go 0, 2, 4, I think. No, actually we're gonna say just seed, and we're gonna do modulo because we want to switch to be driven, right? So this is the seed. And then if you do a modulo 4, that should always give me, maybe not like this. No, let's copy this. This should work. Let me see. Okay, so even if it's like, it's always going to be modulo 4, so it's going to be between 0 and 4 with random values. So it's always going to give me a different height, different overall shape, you know, a bit more octagonal, some circular, some squarish. All right, so this is, we are good here. So this is now, let's put this in a network box. Let's save our file. We're gonna call these building blocks. We're gonna call this base shape. Now, I need to prepare my base shape. Meanwhile, this could be sped up if you put in a compile sub, but I mean, we're gonna do a lot of compile subs, I think, down somewhere here. I think there's one here, I don't know. I think there's one here. So this part is fairly quick to copy, so there's really no need. Okay, this is the longest part, I believe, but it's worth it. Let's now do a little cleanup. So I don't want color. Actually, let's just remove the color from here, to be honest. Okay, we don't need color. It looks fancy, but we don't need it. We don't need. No, that's all we're good. Okay. We had a cluster value attribute because we are going to run I think the loop as a, we change the seed and everything change. Okay, let's promote the seed, the cluster value. Actually, I don't even need that anymore based on this part, but let's keep it in case you guys wanna have, if you want to have some part of the building circular, some part of the building octagonal, like made out of these at the same time, cluster values will come handy because we could use the cluster values to drive the which switch to be picked, but maybe some other time. We don't plan to do it like this. Okay, but never mind. Let's continue with what we were doing. So let's drop in an attribute promote. So I have a cluster value. It will be always based on different numbers. This can be used. This can be used later on for coloration, so on and so forth. But I'm promoting this to primitive now. First match. So if I go here, I have some, cluster values. Now I'm going to create a cluster ID attribute wrangle. Let's say this runs on primitives now, obviously. S at cluster ID equals, so later on if I need, I can pack them by clusters. Cluster, I should have probably prepared this a little better because some of these are not relevant now, but they might come useful. So what did I did is that now these are names. I can actually pack them if I want to pack these, but I don't need this for this tutorial, but this is a way to pack objects nevertheless, and it's called cluster ID, so I can say cluster ID, and it's gonna give me 6 objects based on clusters. It's not a bad thing if you need to group the result and to do simulations, or this is actually, if it's packed like this later on, if there's it could be used for optimization because a packed object doesn't load everything at the same time, so on and so forth. It's useful. So we packed it now. We keep this. So I want to sort the point IDs based on X. In this case, I'm using X. Oh, actually, this one is really not necessary because we are creating everything at the row center. Okay. Okay, this is all good. Now, let's clean up a little bit of our geometry. So this is actually, I have encapsulated this in all one group here. This is kind of like the step 1. It's ready to be now Boolean. Step 1. Let's go step 2. So this is going to be a null here. Okay, let's keep it this way. Out base shape. Okay. Now what I'm doing is unpacking my main object again. So we didn't really have to pack it, but if you want to isolate sections, work in a smaller area, you know, it's a bit easier. Or even you can at this point loop separate objects. Things will go faster. It can stay as is, but for the simplicity of this tutorial, we're not gonna do it. It's like it will be, if this was only for simulation, if it was only for rendering, and if you had thousands of these, you know, it's better to send one object like this as a wedge to the farm than sending the whole thing. So that's why we have these packed objects. Okay, so I'm going to put a Boolean now and change it to intersect, and I'm going to turn off correct normals on reverse faces, and I'm going to save, because this is a very crashy operation. So let it cook. Okay, so now if you look inside, we have a whole nice empty space, and except this guy, because there was this empty space there, but it's fine. To solve problems like these, you just need to scatter a little bit more points, but this is not a problem. It's like an elevator shaft inside, I guess. So what I want to do now is I want to create a null, and I want to keep this as my out proxy. Okay, we're going to capture this. This data will come useful. Now we need to start creating floors. I want to create a line, and I want to create a line that goes the same height as this guy, right? And how do I do it? Is I have a Python sub here. Python sub. This was also in the same previous tutorial. I did parameter interface. Let's drop in a float. And I'm going to get, let's call this actually height. I don't know why I did this with the ingeo. Ingeo is, where is ingeo? Ingeo. Okay, this is name. I named this ingeo because I'm gonna reference this, so just rename this as ingeo. Okay, let's paste this. So this is going to get the dy size. This is 411 from ingeo, which is just a little typo there. So it's 411 meters. Okay. Now what I'm doing is I have another attribute called floor height. Let's put this one is a float also. Floor height. So my floors are 6 meters height. In the future there is too much space upwards, so this is how I ended up, but you can feel free to change it. And now let me put this little the node itself is called, sorry, this is also important, floor calc. So let's now write a little piece of code. Section height equals who, this is also just to show a little bit of because we can do this exact same thing without using Python. but it's just a bit, I think it's just to show, you know. So who.eval parm reads values in Python. Who.evaluate parameter, pretty much, and then you point it to the attribute, which in this case is /obj / building generator, right? / floor calc height, close parentheses, this guy, yes, okay. Next, you're gonna say minimum height is 5, maximum height is 10 meters. So the floor height therefore should be equal to integer section height divided by minimum height. Therefore, height equals to who.parm. I'm not missing anything, right? No. Who.parm /obj / building generator / again floor calc I feel like I'm doing something here. No, floor height. No, I'm not using. Yes, it is. Floor height. Yeah, 62. This is gonna be the result. I think that was my bad at the beginning. We are gonna set that value now to another value, which is be driven by this. So basically here we learn how to read a value inside Houdini using a value inside Houdini using Python. Now we're going to learn how to edit a parameter using Python. Who.parm floor height. The typos are important. We'll have to double check. Set floor height. I missed the double quote. Shift. Okay, there's a typo somewhere. Node.parm floor height. 1 second. Floor calculator. Yes. Height. Is this correct? Floor height. Floor height. Like this. Height. Height. Okay, let me pause it and read this through. Okay, so yes, typo. It was F as opposed to F. That's why these things are finicky. So I change the value now. If I run it again, it's gonna set it to 82. Okay, so it's just randomizing the floor heights in a not very efficient way, but you know, it's the tutorial is all about learning, so we did it this way. It's just a little, you know, applying a little mathematical function here. Is something divided by something else. Okay, so let's drop in now another attribute WOP. So I'm doing some, we're going to decide on the length of this, I guess, point. Okay. So we're going to get the height of our object first. Let's set a constant. This is not animatable, so we can get our height here, copy parameter, paste it into this guy. All right, so that's 411. Now let's get a fit range. We are going to promote all these 4 of them. Promote, 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 promote. If you double click, they'll extend themselves. SRC means, so actually, sorry, I don't need this. What I'm going to do is minimum to minimum and destination minimum, destination max. And I don't even remember why I did this, but now I think we're trying to get the height divided to figure out the floor gap. I'm not entirely sure, to be fair. If I understand it, I'll get back to it. I apologize. So let's put a mix. Actually, I think this would just make sense if I just copied this. I'm not entirely sure why this happened, but let's paste it. Let's copy this. Okay, delete. You go there. This doesn't even do anything, to be honest. I think it outputs a value called floor gap, and to be honest, it's 5 based on the height of the building divided by a minimum value and a maximum value, which is 2.5 to 5. So the minimum value of the floors can be 2.5. The maximum value of the floor heights can be 5 meter. And it's using the building height as a bias, I guess, to create a little random value, which is then clamped into 3 to 5. So it's actually, I think I should have just created a random here. This is probably, I probably tried to do something cool, didn't end up. So I think we should probably just do it, create a random based on, okay, I think I owe that clarification. Create a random value based on floor height, then fit it to some humane sizes, which is 2 to 4 meters, let's say, or 5. Based on this, let's say 3 to 5. So this, we stick to those. And then I think this is kinda, that makes more sense, I guess. And then we can, because we shouldn't probably have 4.2 meter floor, so let's just floor it to 4 meters, or, you know, ceiling it so we don't get 1 meter as well. Yeah, let's do a ceiling. Okay, I think this is a smarter way to generate a random number, to be fair. Let's stick to this. Just a random number for floor gap, which we could have probably done in Wex. Anyhow, now let's go to line. Let's get the height to be pasted as our length. Obviously the buildings go upwards, so, and it's always in the center, our buildings, so we're going to just say 0 to 1, and this is pretty much it with 2 points. Now we're going to get a resample. And we're going to get that floor gap attribute from the detail attribute, which is just a detail of this, pretty much. It's like, this is how you fetch detail attributes. You use a detail, you put the path, and then you write the floor gap, which is the name of the attribute, and then you get the first value, because it's not a vector. If it was a vector, 0, 1, 2 would be x, y, z. If you're confused about the code, you can always click anywhere on the function, hit F1, and then Houdini will open up the function for you, so you can see how it works. A nice example here. Okay, so now if I go to the points, basically I should have points with the difference of 5 meters pretty much. The next thing I'm going to do is I'm going to remove, which point am I removing here? I think I'm removing the first point or the last point. Let me check on my scene here. Yes, I'm removing this top floor. I think this was because I end up with walls with no ceiling, so it's easy to do. I can say if at point number is equal to n points on self. N points gives you the total number of points minus 1, obviously. Remove point 0 at pt num. So what does that mean? N points gives us all the points, which is 83. So if I look up here, turn on the point numbers, let's do it here. The last point is 83 because it's the point number 0, because these are point numbers, so 0 also counts. So I want to remove this last guy, which is n points. Why is it erring? Semicolon. So now it should be removing the last point. Okay, remove. Let's call it remove last point. All right, now let's create a grid. So this grid needs to have slightly bigger size than our InGeo here, right? So we can just use the bbox expression. So bbox, so we're trying to get the DSX size, so 121, right? And then I'm multiplying it by 110%. So it gives me, instead of 121, it's going to give me 131-ish, 122, yeah, sorry, because 0.1, okay. So slightly bigger. And this is Z size. And I'm going to do the same thing for this. Actually, this doesn't matter. This looks like they're swapped, but it doesn't matter because it's a squarish object. Now rows 2 by 2 because I really don't need extra detail. Now let's do a copy swap. Copy 2 points. No, sorry, like this, like this. Now we scattered our floor base geo, and now let's create another attribute wrangle. These don't have to be packed. You don't need any of these, to be honest. We want UVs, and they can be overlapping UVs at this point, at least. So you just have to do it once if you do it here. UV texture, sorry. UV texture. I think orthographic is fine. Okay. Now I want to make sure that I know my floor values, floor IDs. So then on primitives we can say I at floor equals at primnum, because each one of these squares is one primitive. So if I look here, I have 82 floors. Okay. Now we're going to do a little Boolean. And what do we do before we do Booleans? We save. File save. Now let's get the proxy on the left. Now the right side is the surface. So with the surface, and we're going to set this to intersect because we want to capture what's intersecting, right? And then we plug this guy here, let it cook, and now we have our floor geo cut out as well. So we're kind of getting there. Normals are all messed up. we're gonna do some other Boolean operations, but this is gonna come after. So let's continue down the chain. I am also generating an attribute called measure to get rid of small areas. So I'm gonna show you how I did it, but then there's a better tool now. You can probably use that one. Measuring area, and then dropping a wrangle to say if anything is less than 200, remove primitives. In this case there isn't, but based on the size, shape, there could be some really small areas that are stuck, but we don't need to. But the other good tool about this one is the labs has something like this. If you type small, if you have the labs installed, I'm not going to show you it's installed, but you can go to the website. I think it's even, to be honest, you can install it. I actually don't know. There's a tool, I think somewhere it says install labs, maybe here. I don't know. There's a website at the side effects website. There's a I think link for it. Side effects labs here. I think you did that, and then you say install. Yeah, install. There's an update apparently, which I should. But this does the same thing. I can put this guy here. Oh, no, don't quit. Okay, I'm not gonna use this. Save and quit. Okay, let's launch it back. Unexpected behavior. Let's open up our last file. So therefore, that's why it's good to save quite often. Now it's gonna cook. Okay, let it cook. A second. Yes. So I guess I need to update this. So it doesn't want to work. So let's delete it anyway. I didn't use it anyway, so no need. Okay. Let's continue with our floors. Now we're gonna extrude floor by using extrude poly extrude gets plugged in. We go distance 0.5. Gives us some thickness. That's half a meter, by the way. So these are really big objects. Turn on these outputs, and we want the side group to be exported as well. We are exporting towards point normal. And I think this extrusion is pretty much that. Now what I'm going to do is that I'm going to put a transform, and transform this -5 meters again, and I'm going to merge the two, creating even thicker floors. 1 second, let me see this. This is not correct. Let me check on my other scene. It's actually correct. I just don't remember why I was doing this, because I'm kind of offsetting the upper floor to one down and then merging it. This is probably not even necessary, but I'm not gonna skip that. I may have had a good reason why. Anyway, since we're gonna do another Boolean here and do a union, not actually, I'm not going to do this one because this just doesn't make much sense. I was probably trying to build something that end up not doing it. So let's put a group swap. Let's create a primitive group called floors. Now let's create a material as well. Actually, I think I set these materials at the end. Oh. Yeah, probably not gonna do it here, but no, it's let's do it so we don't defer too much. All right, let's create an attribute create. This time you can also create attributes using attribute create. And now here I call it material. Create a local variable. It's a primitive. It's a string, and it's called $us. And the name is ID floor, later to be used for partitioning or creating materials, hooking up materials. Okay, now null. This is our first step of our floor. We're gonna manipulate that a little bit later. Let's pull this guy up. Let's pull this guy up. This is our proxy. Let's pull these guys a bit down and let's group these as floor. Okay. Now let me see. I think this video is now long enough. So let's stop this, and then I'll probably start a new file called part 2. Actually, let's do that. File, save as. Let's save this first, and then file, save as part 2. Okay, so we are getting somewhere. See you in the next video.